Hello and welcome back to the channel, guys. In today's short video, we will be discussing what is concurrency and how concurrency is achieved in Go by means of Goroutines. Let us start our discussion by trying to understand what is concurrency. So here it says that concurrency is the ability of different parts or units of a program, algorithm, or a problem to be executed out of order or in partial order without affecting the final outcome of the program. So what this means is that if a concurrent program is broken down into n number of concurrent parts, the final output of that program would not depend in any way on the order in which those n concurrent parts of the programs had gotten executed. Now, what is the benefit of concurrency? Well, concurrency leads to a very important concept which is called parallelism. So, concurrency allows for parallel execution of the concurrent units, which can significantly improve the overall speed of execution, especially in multiprocessor and multi-core systems. Therefore, parallelism is the result of concurrency. To understand concurrency and parallelism better, let us quickly see a very short and a very simple example from day-to-day life. Suppose I have to solve this very simple mathematical equation 1 plus 2 whole bracket multiplied by 3 plus 4 whole bracket. So the first way of calculating the result of this simple mathematical equation is that I first calculate the result of 1 plus 2, which is 3. Then I calculate the result of 3 plus 4, which is 7. And then I multiply 3 and 7 to get 221. Another way of calculating the same equation would be that I first calculate the result of 3 plus 4, which is 7, and then I calculate the result of 1 plus 2, which is 3, and then I multiply 3 by 7, and which gives me 21. Now, by this time, you might have noticed that it does not matter whether I calculate 1 plus 2 before 3 plus 4 or I calculate 3 plus 4 before 1 plus 2. Because no matter in what order I do these calculations, the final result will be the same, which is 21. So we can say that for this operation or for this program or for this algorithm, whatever you want to call it, 1 plus 2 and 3 plus 4 are concurrent units of execution. So what can we do as a result of this? Well, we can run both of these operations in parallel, and the same calculation which was taking us 3 steps will now be reduced to 2 steps. As you can see, we calculate 1 plus 2 and 3 plus 4 parallelly. We get the outputs 3 and 7, and when we multiply 3 by 7, we get the output of 21. So in this whole process, by running the concurrent parts of our program or our algorithm in parallel, we have reduced the number of steps required to get to the final output without affecting the correctness of the final output. And by now, I hope that you have understood what is concurrency, what is parallelism, and how the use of these concepts can help us improve our overall speed of execution. But it will be useful only if we have multiprocessor and multi-core systems. Next, let us discuss about threads. Now, concurrency is achieved in most programming language by means of threads. So, most programming languages make use of OS threads, which are threads that are managed, scheduled, and so on by the operating system. This means that the threads have an individual function call stack that is dedicated to the execution of that thread. As a result of this, these threads just end up taking too many resources. Their memory allocation might go as large as 1 MB. They take a lot of time to set up and so on. There are various kind of drawbacks for these threads. This also leads to concepts such as thread pools, because creation and destruction of these threads is very resource intensive. And well, Go comes to the rescue with Goroutines. Let us now try to understand the concept of Goroutines as well as green threads. So Go threads are actually green threads. Now you might be wondering, what are green threads? Well, green threads are simply threads that are not managed by an underlying operating system, but are managed either by user programs or user libraries and so on. So instead of having massively heavy and resource intensive threads, Go has actually, or the Go runtime has actually created an abstraction of threads which is called a Go routine. Now, this Go runtime also has a scheduler which keeps on mapping or assigning these Go routines onto various OS threads for certain periods of time so that each thread could eventually run, or each Go routine could eventually run to completion. And as a programmer, we do not interact with the low level threads of the operating system, but we interact with the high level Go routines provided to us by the Go runtime. Now, what are the advantages of this programming model? Well, Go routines can be started with very, very small stack spaces, which means they are not as resource intensive. As they are very resource effective, they can be reallocated very, very quickly and can be easily created and can be easily destroyed without much overhead. In a Go application, as a result of these characteristics, we can have thousands of Go routines and not have any issues. Apart from that, threads in other languages with 1 MB of overhead cannot ever scale in this manner. Now, those were the theory aspects of concurrency, parallelism, threads, and Go routines. Now, let us see all of this in action. We are back at Visual Studio Code and we have a very simple program on our screen. We have a main function which prints main starts and it should be main ends. And between these two print statements, it calls the hello function with the argument 1. The hello function prints its argument along with the string hello. When we try to run this program, we see that main starts, then we see 1 colon hello 5 times, and then we see main, okay. We should see main ends, and yes, we see main ends. Now, the first thing to note here is that each and every Go program has at least one Go routine which runs the main function. And if we decide to spawn more Go routines, then our program will have more than one Go routine, but each program will have at least one Go routine which will run the main function. What I'm going to do next is I am literally going to use 3 keystrokes, which will be G, O, and a spacebar to make this program a concurrent program. So what I will do is I will simply say G, O, space. I will save this program, and now the hello function, which was first executing sequentially, will start executing in a separate Go routine of its own. So let's go ahead and try to run this and you'll be very surprised. Well, we see the output is only main starts and main ends, and although this function is called, we see no output from this function, or we can say from this Go routine. Now, why did this happen? Well, this happened because the main function or the main Go routine finished much more earlier as compared to the Go routine which was running the hello function. So the way I am going to solve this here is I am simply going to make the main Go routine go to sleep for a certain amount of time, and for that I simply say time.sleep 100 into time.millisecond, which is equal to 100 milliseconds. When I save this and try to run this program, we see that we get the output of two Go routines. Here is the output of the main Go routine, and here is the output of the Go routine running the hello function. And I mean, I find this extremely cool. I mean, just imagine, you don't have to extend the thread class, you don't have to implement the runnable class. All you have to do is hit 3 keystrokes, which are G, O, and space, and you have achieved concurrency. It really, really, really cannot get simpler than this. Now, some of you might argue it just seems that everything is running in a sequence. First, we see the output for the main Go routine, and then we see the output for the hello Go routine. So what I'll do here is I'll simply copy this call to the hello function 5 times, and I will give it different arguments each time. Let us now try to run this program and see what happens. Well, at this point of time, again, the outputs seem sequential. Let's try to go ahead and run this one more time. And yeah, as you can see, this time we are seeing very interleaved outputs. You can see 4, 3, then 4 again, then 3, then 1, then 2, and then 3 again, and then 1 again, which shows that these Go routines are running in parallel. Maybe I could just decrease the number of times the for loop is running, and we might actually see a better output. Let's get rid of the 5. Let's clear the terminal, and when we run this, yeah, as we can see that the outputs are interleaved. We see 2, 2, then we see 4, 4, 4, then we see 3, 2, 3, and 3, which again shows us that these Go routines are running concurrently or in parallel. Next, instead of using the hello function for spinning up a Go routine, I would like to spin up a Go routine using an anonymous function. So right here we have an anonymous function, which is an unnamed function, and right here itself the function is being called. So what happens when I try to run this program? Let's say go run example.go, and we see the output of the anonymous function here as well. The function is simply printing the string msg. Alright, next we would run this anonymous function within a Go routine, and then again we'll hit 3 keystrokes go and space, save the program and run it one more time, and yeah, we can see the output of the anonymous function. It prints hello at the end of main starts and main ends. But I wonder what will happen if after I ask the Go runtime to create a Go routine for this anonymous function, I actually end up changing the value of the variable message. So if the value becomes world, let us see how the program behaves now. And we see that this time the output that we actually see is the string world. Now, what we have actually done in this program is that we have introduced a race condition in which the same piece of data is being accessed in the main Go routine as well as in the Go routine for the anonymous function as well. Now, race conditions are not healthy. They should never ever exist within your programs, because that will give you unexpected outputs and your applications will end up having a lot of bugs because of these race conditions. The Go runtime, however, gives us a functionality by which we can check our programs for race conditions. So if I go ahead and say go run minus race example.go, it shows me a warning. So it runs my program and we see the output here, but it shows me a warning that there is a certain data race, and Go has found that there is one data race in our program. And it shows us that there is a certain read by goroutine 7 at line number 13 in example.go, and there is a write by goroutine. You can see that the memory address is the same by goroutine. This time we don't see the goroutine number, and the place where the write happens is example.go and line number 15, which are these line and this line. So it's really essential that when we are writing concurrent programs, we check our programs for race conditions and avoid them at all costs. Now I am going to fix this program, and the way I am going to do this is by passing an argument within this anonymous function. So we will change the definition of the function to accept an argument m, which will be of type string. Here we will simply print the argument m, and here we will be passing the argument msg. So let us try to run this program first and see what is the output. Well, yes, this time we see the output hello, and even though we change the value of the variable msg and set it equal to world, we see the output of hello on our screen. If I go ahead and say go run -race example.go, we see that this time we do not receive a warning for any race conditions in our program. And that's all we wanted to discuss about Go routines. All of the code that we just saw has been updated in this GitHub repository ae.dorado/learninggo. So please do check it out as well. The file name is goroutines.go. If you found the content of the video helpful, please do hit the like button. If you find the content of my channel helpful, please do click subscribe. You can hit the bell icon to never miss any new updates. Like always, thanks a lot for watching, and I'll see you very soon in a brand new tutorial.